Friends, welcome to my YouTube channel. Friends, today we are going to discuss the Gerber criteria. It is a very important criteria of failure which is used to design the component which are subjected to the fluctuating loading condition. So let's start the topic without wasting any time. Friends, the first thing that we should remember is that this criteria of failure is valid for fluctuating loading condition. That is when the loading is varying like this, that is shown in the right side of the screen. This is the figure for the fluctuating loading condition. In this figure, the stress is varying from certain minimum value and going to certain maximum value, and again going to certain minimum value, and again going to certain maximum value. And there are two terms which are very important for the to understand this fluctuating loading condition. These are the mean stress and the stress amplitude. The formula for the mean stress is given on the right side of the screen, and the formula for stress amplitude is also given there. And friends, we have to keep in mind the second thing, that this Gerber criteria is used whenever we design the component for infinite life. That whenever we design the component for infinite life, then we will use this Gerber criteria of failure. Now in the next step we will find out the equation of the Gerber parabola, and also we will see the safe region and unsafe region. So friends, this is the Gerber parabola. See on the right side of your screen. It is a curve which is joining the SUT, that is the ultimate tensile strength, on the sigma m axis, and it is connecting a point SE, that is the corrected endurance limit SE, on the sigma a axis. So this curve is called as the Gerber curve. Okay, and let us see which are the safe region and which are the failure region. All the regions that are lying outside this curve are lying under unsafe region, because the coordinate of all the points which lie in this region are unsafe, and all the points which lie inside this curve are safe for the design purpose. So we will in the next step will try to obtain an equation for this curve. So we will here find out the equation of the Gerber parabola from the experiment and the data which has been plotted. To find out the equation for this parabola, the equation will come out to be like this: sigma a by SE is plus sigma m by SUT whole square is equal to 1 upon factor of safety. So this is the equation for the Gerber criteria. We have to use this equation to design the component which are subjected to the fluctuating loading condition according to the Gerber criteria. Okay friends, there are few things that are very important in designing when we are going to design with Gerber criteria. The first thing is that here SE is the corrected endurance limit, which is denoted by SE. Here the value of SE is given as SE is equal to KA, KS, KR, KD, KL, SE dash. Here SE dash is the endurance limit in reversed bending condition, that is the endurance limit which has been obtained from the rotating beam test. Okay, that is from the fatigue testing machine. And here the factor K is the size factor, Ks is the surface finish factor, Kr is the reliability factor, Kd is the modifying factor to account for stress concentration, and Kl is the load factor. Now we have to find out the value of these factor, and the value of this will be provided to us or can be taken from data book, so that we can find out the corrected endurance limit. Now friends, see this Ka, Ks, Kr, Kd and Kl can be given in the question or can be taken from the design data book. So these factor can be taken from design data book, or second case is that these factor can be given in the question, that is the K, Ks, Kr, Kd, these factor can be given in the question. And the third thing is that the factor are not given in the question, neither we have data book, but we have the problem in front of us. Then what we will do, then we will take each of these factor as unity in that case. And the fourth case is that when some of the factors among these factors are given to us and some factors are not given to us, and we do not have data book and question is asked to us, then what we will do, we will take the factor which are not given to us as unity, and the factor which are given to us will be substituted as it is in the formula. Okay friend, so these are the 4 cases, and we can decide on the basis of these 4 cases the value of AC, that is the corrected endurance limit. So friend, according to GATE examination, you should particularly deal with these 2 cases, that is the case number 3 and the case number 4. So you should keep this thing in your mind. Now friend, let us see another thing, that is the 4th point. The 4th point says that the value of sigma m and sigma a must always be substituted with positive sign. They may come negative according to these 2 formula, but they must be substituted with positive sign in this equation. Now friend, the 5th point is that this equation is valid for the case of fluctuating axial loading. That is, this equation can be applied for fluctuating loading condition, or this equation can be applied for fluctuating bending condition, fluctuating bending loading. But for the case of fluctuating shear loading, that is fluctuating torsional loading, this formula is not applicable. Then what we have to do? We have to derive a formula or write a formula for fluctuating torsional loading. So I am writing a formula for fluctuating torsional loading here. See friends, the formula is very simple. In place of sigma a, you have to write what? Tau a. And in place of sigma m here, you have to write tau m here. And in place of SE, you will substitute SE as it is. And in place of SUT, you have to write SUS. And the equation is almost same. Now here, you have to note down that tau a is the shear stress amplitude. Okay. And tau m is the mean shear stress, and tau a is given as sigma max minus sigma min divided by 2. Sorry, tau is given by tau max minus tau min divided by 2, and tau m is given by tau max plus tau min divided by 2. That is in the similar fashion that we have find out sigma m and sigma a. Now friends, the next thing here is the SUS, that is the ultimate shear strength. Ultimate shear strength. Here SUS denote the ultimate shear strength, and SE, the corrected endurance limit, can be find out in the similar way that we have find out in the case number 1. Okay, that I have already explained you. So this is the all for today's topic, and friend, if you like my video, you can subscribe to my channel and also press the bell icon. Also friend, this is a very important topic for the GATE purpose, so you should better learn this topic very carefully. And also friend, will be uploading a numerical problem over this topic, so you should watch that numerical problem also, so that you can solidify your concepts. So thank you friend for watching this video.